Some of them get a little bit confusing. For instance, when do you multiply and when do you add your exponents? So let's go ahead and get our basic properties of our exponents down. Is everybody good? All right, so if we remember, whoa, what's going on here? Got all sorts of craziness going on. If we remember, if we have an exponent, if we have a to some exponent, let's say n, we would rewrite that as that many a's n times. Okay, which is your basic one. If I had 3 squared, then it's 3 times 3. If I had x to the 4th, then it's x times x times x times x. If I had b to the 5th, then it would be the product of 5 b's. So that's just what your integer exponents are. You all remembered, hopefully, for 19 through 22, that anything to a 0 power, doesn't matter how complicated it is always going to be 1. And then those negative exponents, which always seem to throw us through a loop, need to be converted to a positive exponent by sending it to either the denominator, or if it's in the denominator, sending it up to the numerator. So you're taking the reciprocal of it. Okay, so if you have anything to a negative exponent, that's going to be equal to 1 over a to the n. If I had 1 over a to the negative n, then it would go where to make it become positive? It would go back up to the top. Right? I'm not going to jot that down or not. So if we had 1 over a to the negative n, that would be equal to a to the positive n. So for all of these problems, when we go to simplify our exponents, we want positive exponents. And I want to make sure that I can simplify them all the way down so that I only have one base available. Okay, so those are all our different integer exponents. Now let's look at our properties. So these are your properties. You do not need to memorize these names of them. You just need to know how to do them. So our first property is the product of powers property. I don't remember if I have these up here or not. Nope, I don't. Power of a power, yeah. All right, product means what? Multiplication. So, I like x's. We'll deal with x's. If I had x to some exponent, and I were to multiply it with the same base of some exponent, what would you do with n and m? Add them together, so it would be whatever n plus m would be. So if it was a 4 and then a 5, it would be 9. If it was a 3 and a 4, it would be 10. If I had a quotient of powers, so instead of multiplying my two powers together, we did a quotient of powers. So let's say we had x to the n divided by x to the m. So I wrote that kind of big. X to the n divided by x to the m. Then what do you do with your exponents?
You
subtract the exponents. So x to the n minus m. Power of a power. So that's when you have a power and you take it to a whole nother power. So if I had x to the n being taken to the m power, then what do I do with my exponents?
X to the n times m power.
Good. So just multiply. N times m. Power of a product. So if I have two different things, or 3 or 4 or 5, it doesn't matter how many different terms I have inside of my parentheses, and I were to take it to a certain power, we need to make sure we have both of those terms taken to that one power. So xy to the nth power would equal x to the nth, y to the nth. And then the same thing happens for a quotient. So instead of multiplying x and y, if I were to divide x and y to an nth power, it would just become x to the nth divided by y to the nth. Okay.
Which then you kind of done to get the quotient of powers?
Well, that would only work if my bases were the same. And here my bases are not the same, so I wouldn't be able to do anything else with that. All right, let's see it in practice. Very good. Okay. Got it, Avery? Okay. All right, first example. Simplify 3x squared y to the negative 2 times negative 2 x to the third y to the negative 4. Now me personally, I don't know if you've figured it out yet, I like to try to keep myself organized. So when I get to problems like this, I try to organize my thoughts. Some of you guys can just go right through and do what it is that you need to do. But I'm going to show you my process of organizing, and then if you want to go with it, go with it. If you think you can do it without, then do it without. That's up to you. But what I like to do is I like to organize all of my like features in this problem. So right now I have a constant number of 3. Do I have any other constant numbers? Yeah, negative 2. So I'm going to write out 3 times negative 2 next to each other. And I can do this because it's a commutative property. Operation here is multiplication, operation here is multiplication, operation here is multiplication, 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 multiplication. Is there anything outside of this parenthesis that I need to take in? No. So I can go right to moving things around. All right, now I'm going to do the same thing for my x's. I have an x squared here. Here I have an x to the third. And I'm going to group my y's together. So I have a y to the negative 2, and I have a y to a negative 4. All right, so now it makes it a little bit easier to see what I'm going to be getting when I multiply all these things together. What is 3 times negative 2? Negative 6. X to the second times x to the third is x to the 5, the 5th power. Y to the negative 2 times y to the negative 4 would become y to the negative 6. Okay. All right, I'm almost done. I only have one negative exponent. Even though my 6 is a negative 6, it's not a negative exponent, so I'm not going to touch it. I'm not going to touch the x to the 5th, but where am I going to send the y to the negative 6 to make it become positive? Send it down to the bottom. So then I get negative 6, x to the 5th, all over y to the positive 6. Simplified. Okay. For some reason, people hate exponents. I don't know why. It's like kind of like thoughtless work. Just gotta do it step by step. Organize what it is you're doing and just keep simplifying. As long as you know your properties, they should be really easy problems. They just look crazy. All right, let's do another one. This is exiting out. We have a negative y to the 7th power being divided by 2 z to the 12th, y to the 3rd. Do I have any exponents on the outside of that parenthesis? No. So I don't need to move any, or I don't have to take that power to a power for anything. Alrighty. Do I have any constants up here? Technically I do, right? It's -1. But is that going to simplify if I take -1 and divide it by 2? No. If that was a -4, -4 divided by 2 is what? -2. So that would simplify. All right, so now let's just focus on our x and our y's and our z's. If you want, you can break it apart. I probably wouldn't. It would be pretty useless. But if we go with the idea of separating everything, I have a -1 and a 2 for my constants. Here I have a y to the 7th. On the bottom, I have a y to the 3rd. Here I have a z to the 12th in my denominator. Do I have any z's in my numerator? No. So what's the only portion of this problem that needs to be simplified? The y's. They would go to how many y's? 4. In the numerator or in the denominator? Numerator. Because you have the highest number of y's in the numerator, when you go to cancel them out, you're going to be left with that many y's in the numerator. So now I'm just going to rewrite this as one big fraction. So we know that this is going to y to the 4th. So in my numerator here I have a -1. In my numerator here I have a y to the 4th. Do I have anything here in my numerator? I mean, technically it's going to be what? 1. So -1 times y to the 4th times 1 is -y to the 4th. Now in my denominator, I'm left with what? 2 and z to the 12th. Good. Okay. So is it necessary to break it up like this? Probably not so much on this problem, but when you start getting a lot of things happening, sometimes it's easier to break it up individually and go from there. Okay. All right, let's step up our game a little bit more. Why not? We're up for the challenge. Let's do a quick practice. See if you can do this one on your own. So we have x to the -2 times x to the -3 to the 4th power. Fractions or problems, and it's really simple. You guys are all going to have a calculator on you. So just quickly look up here. If I need to evaluate 16 to the 1/4 power, how would you type that into your calculator?
16 with a little caret.
Yeah, 16, and then you hit the little caret button. Looks like this. Okay. If you have an 84, it'll probably pop it up into the little exponent into that spot. But I would put parentheses just to be safe to turn that into the fraction. So this would be your division sign. So 16 to the 1/4. So can everybody just practice that right now on your calculator and make sure we all get the same number? Yeah, it should be 2, right? Is everybody getting 2? And then 27 to the 4/3 power, again, will be the same thing. If you had to do this by hand, how could I rewrite, what number to the 4th power is 16? 4 to the 4th isn't 16. 2 to the 4th is the same as 16, right? And if I take that to the 1/4 power, what do I do? What do I get when I do my power to a power?
1.
It becomes 1, right? Which is where that 2 comes from. So if you have to do it by hand, that's where it comes from. Interesting, huh? 27 is 3 to the 3rd, to the 4/3. So it would be the same as 3 to the 4th. That's why 81. Okay. All right, make sure you get the homework written down before you exit. Have fun tonight working on those crazy exponent problems.
We will.
I did give you mostly odds, so you should be able to check your answers in the back of the book. But you should be doing all of your work. So I don't think that you just went and copied the answers down.